Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
And we're off with another video, continuing with our object-based image classification. So this is going to be a video that follows on the previous ones, but in this case, we're just going to play around a bit. Okay, so just playing around with specifically all the different models or algorithms, and let's just see what happens. Now, this is the beauty of what we're doing, is in that there's no limits to what we can and can't do. So we'll just play around for this video, have some fun, and see what it takes us. Ultimately, if we can learn by having fun, why not? But before we go, please, boys and girls, like and subscribe the channel. Please share the channel. Please support the channel. Let's go. Let's make those numbers happen. Let's make the numbers happen. So just again, as I said, play around, go and surf the channel, support the channel. I'll really appreciate it. So with that said, yeah, by the way, as I said, we've done 4 videos now on object-based image classification. And this will be the 5th one. And I said it's a combination of all these things. We're just playing around, having some fun. Remember, object-based classification, we've got our stack raster. And the first thing that we do with our stack raster is to do the image segmentation using the OTB Toolbox. Okay. And getting the image classification as correct as possible is very, very important. And to a large degree, the more segments you have, the more individual segments that you have, the better. Obviously, there is a point where it's too much, but rather err on the more than the less side. Once we've done the zonal statistics, we've done the joint layer, we do all of those things. And then, apologies, the 2 important parts. One is training of our classifier, and then the actual classification itself. And I said, handy tip, keep these 2 windows open. Don't close them. Keep them open throughout the whole process. It just simplifies and makes life so much easier. So don't close them. Just minimize them and keep them and work within them. Okay. So remember, our first thing is the train vector classifier. Okay. In our OTB under learning, there it sits. Train vector classifier and then vector classifier. So those are the 2 things that we're going to work with. Remember, there's a whole lot of other useful algorithms that we can use as well for other work, but for now, this is what we're going to stick with. Okay. So remember, in our training, our input vector data is our training samples with the associated band statistics. Okay, so remember the one here, we've got that is segment 2. Remember, it is our segments that is associated with our samples, our training samples, you'll see there. So all of these segments are related to our training samples. And then obviously we've added to this, if I open the attribute table, we've added to this all the statistics of the 11 bands in Sentinel. So that's important there. Then, as I said, we leave the layer index. We can leave this open. But what is important here is the field names of the training. Which of those statistics? Let's open it again. Which of these statistics within these individual segments, training segments, which of these are we going to use? Which of these are we going to use? Okay. And in my case, I'm using all the mean band values for each band. There's a mean for band 0, band 1, etc., etc. Now, you can choose all of them. You can choose very little of them. Again, that is going to be something that we're gonna exercise. Okay. Then, interestingly enough, what I want to do, I actually want to, for this time, include our uh, validation data. However, I haven't yet added. Now, the validation data will be this test assessment. Remember which we used? You see, they are alternative samples. Feature samples within our region of interest that we've used in our normal object, pixel-based, to assess the accuracy of our classification. Now, what we can do is, remember, these are also, if I open attribute, they're also all of these, but there's no statistics in this. So what we can also do is to add the statistics of the specific one so that it looks similar to the join layer. Anyway, let's for now just leave it now, but yeah, we can do that. Layer index, and remember then this is important here, is a field containing a class integer. This is what we're gonna be our prediction, and this way we put the class. Okay, meaning if we go into our training value, we open attribute again. This is the class that we're gonna look. We're not gonna look at the integer, we can look at the text column. Okay, then so this is standard stuff. Well, not standard stuff, but this obviously is what you're gonna. This input vector data is the minimum with the class within that, and then the field names. Now, as I said, I'm gonna do this also at some point. Put in the validation vector data, just to see what it does, whether it actually makes a difference or not. Anyway, so again, we can play around with that. We can play around with that. Now, here comes the interesting part, the classifiers. Now, as I said, there's ellipse, boost, DT, ANN, artificial neural network, Bayes, random forest, k-nearest neighbor, shark, random forest, shark, KMM. Don't know exactly what all these things mean, but I'm sure if one can Google them, it should be available there. I've already used the ellipsum and it doesn't seem to work. Let's go and try the boost, see what happens with the boost. And again, start with them from point one, go work for them and see what we figure out. So let's have them loose, and I'm for now, gonna keep the default values. I'm not gonna play around with these default values. Okay, maximum depth, speed, width training, weak account, real. What's the options there? Discrete, real, logic, gentle. We're going to play around with it now quickly. So first we're going to just see if this works. Boost output model. So we're going to go, and then confusion matrix we can do. That was just check the accuracy. We're going to go to that and to our one. And we're going to go, and it's going to be segmentation. There's the model. Segmentation. What did we call it previously? What did we call it previously? Did we call it model or what did we call it? Yeah, segmentation. Okay, yeah, so it's this one like that. So it says segmentation. It's gonna be boost, and it's gonna be real, and it's gonna be 100. And it's going to be wait time. Now let's add that as well, just to make sure. 0.95. And we're going to, and obviously dot model. We're going to save. Make sure that and the reason why we go into all the effort of adding all these things, because as I said, we're going to keep on changing and it's easy to lose track which one is which one. So then and then I'm just going to copy this. And we're going to run. Invalid train vector current exception during application. So why is it doing this now? Okay, so let's exclude that. Run. Did we run it now? Say run. Nope. I don't want to run. It's the ID. Run. There we go. Okay. So just confirm. There it wants the integer and not the text. Okay, so that's my fault. So let's quickly get that. Copy. And then here, we're going to obviously, here it will be the segmentation of the entire region of interest with all the associated statistics. So it's this joint layer. So it's not going to be this joint layer. It's going to be the zonal statistics, that one there, which if we go into zonal statistics, you'll see it is this one, which is segmentation of the entire region of interest. And if you go to the open attribute, it's our population with all the statistics. Population of segments with all the statistics. Now what we have to do when we go into field names, it's going to have, and well, remember there's our model file. I'm just going to paste in there, this one here, paste in there. And then remember here now, but the field names must be exactly the same as the field names there. Okay, so we're going to go mean 0, mean 1, mean 2, mean 3, mean 4, mean 5, mean 6, mean 7, mean 8, mean 9, mean 10, and mean 11. Okay, and then we're going to save this. So let me just go there, and we're going to go output vector and save it as a SHP. So here we save it now as the actual image classification map or image vector file. Okay, and we're going to say run. And it's done. I said, don't close this, just minimize it or make it there. Then we're going to go to layer. We're going to say add layer. We're going to go vector. And we're going to go and find that vector file that we've just created. Let's quickly go and find it. Let's go and find it. There's a hell of a lot of these ones already. And it's going to be this one there, boost. And we're going to open. We're going to add. Close. And there it is. Let's just take... I'm going to just delete those ones. And then the assessment. Delete it. So have a look here. Okay. So we're going to go open. Properties. Then we're going to go graduate or categorized. And we're going to find that ID, the predicted. There it is, and we're going to classify. See, it only classifies 1s and 2s. So we're not going to go even further because it classified all of the, go open attribute, all of these segments, it classified it as either 1s or 2s. In fact, everything was 2s. Anything 1? No. So I'm just going to delete it. That's why I keep it. Remove it. So let's see, maybe there's something within the boost. Maybe real, discrete, weak. If we change some of this, maximum depth of the tree, let's make that 6. Just gonna overrun it. So make that 6 because there's 6. Run it. Okay. And then we're gonna run it. See, that's a nice thing if you just keep it. Then you don't have to do everything over again. So let's quickly go and open it now. Segmentation, boost real, open, add. Okay, so let's go now, open properties. And that's what we have to do, is just play around with these things and see what happens. Predicted, classify. Nope, still the same. To do one more, let's remove it, move layer. So boost, for our purposes, is not working. Let's see, random seed. Let's do discrete. Keep that 6, run, and run, and view. Sorry if I keep quiet a little bit, but I don't want to just keep on talking just for the sake of talking. Add. Let's have a look now. Open attribute properties. Let's see, categorize and predicted. Classify. Nope, still the same. Now, just gonna remove it. Now let's quickly see whether it overrides it. So let's do this quickly. I just want to confirm. I'm just gonna put the underscore 1 or make it 6, just for interest. I just want to make sure that it does indeed override. Because sometimes it does not override, and it just keeps the original layer. So let's just keep we did there underscore 6, and just to make sure, just cover all bases. It's always advisable, just cover all bases. But I always make sure it would have done it. So let's just predict it. Yep, no point of boost. So boost, remove layer, not gonna work. And what we can do now, just to clean up the, okay, so we just cleared our, we don't want all these things that we don't use. So I've just deleted those files that we generated the boost. So boost is not boosting. So boosting is not boosting. Okay. We can look at real, logic, gentle. That's fine. But for now, boosting is not boosting. So let's quickly go to DT. So let's make it a little bit bigger. So we're going to go the model segmentation. So that will be DT underscore 10 underscore 10 underscore 0.01 clusters. Let's do that now, and we're going to do the default, and then we're going to copy this one. We're going to run. See how nice it is if we just keep these things open. It just saves so much time and effort. So the model file will be that, and it will be saved in there as a shapefile. There we go. And we're going to run it. Okay, done. So we're going to go view. We're going to go layer. We're going to go open that layer. Close that one. Should be first one coming up. Boost. The DT. So let's open it. Add. And we're going to close it. There it sits. So we're going to go properties. I think you're starting to get the gist of it. Categorized. Predicted. Classify. Oh, there we go. DT. DT is our friend. Okay, so now we're going to go classify. Remember, I saved the style. Load a style. So we're going to load that style. That's the style that we've loaded. Load style. Should be the same as our, okay, let's just apply. And there you go. There it sits. Lots of red. Way too much red. Remember, yeah, there's our training. You can see the training where it trained, yeah, but too much red. Way too much red. Let's quickly just, this is the segmentation of the random forest. First sight, it does look better than the random forest. There's few red, random forest got lots of red. Anyway, okay, so we've got something to work with. Let's see if we significantly alter the parameters to see if anything changes. So, first thing, let's check this, the verbose. Okay, so I'm going to go underscore, so I'm going to keep this and now I have to change this. So I'm going to keep this, done. See if it makes any difference. Verbose and underscore V. Let's run it. Done, done, done. So let's see if there's any difference. Add vector layer, underscore V. I don't have to go and look for it. I can just copy and paste it there as well. Add, close. Let's go that one. Open attribute, not attribute table. I want to go and properties. And then we're going to go graduated. We're going to go predicted. And we're going to go load style. And there we go, load style. We're going to say apply. Okay. Let's have a look. Absolutely. I can't see any difference, eh? And you? There's some stuff happening here at the back. What's happening there? Let's have a look. Nope, no difference. So I'm going to delete it, remove. So now we know. Now again, it's difficult to make a generalization. But for now, it doesn't make a difference. So let's keep it in. Let's take this depth of the tree. Let's see if we make that 100. So we make that 100. And we're going to say run. Let's see what that makes, what that does. Oops. And then remember here we've made that 100 and 100 and we're gonna run the model. Okay, done. And we're gonna layer. We're gonna add layer vector raster. We're gonna make that 100. We're gonna say add, and there we go. So now let's have a look and see. We're gonna go properties. Come on. We're gonna go properties, and we're gonna go categorized, and we're gonna go predicted, classify, and then we're gonna go style, load style, and we're gonna open, load the style, and apply and close. So let's have a look and see. Almost no difference. See that? No difference. No difference between 100 and stuff. So let's make that again 10. Minimum. Make that 100. So that becomes 10 again, and that goes 100. Okay, so run it. And this becomes 10, and that becomes 100. That becomes 10, and that becomes 100. We run it. We just keep track of all these changes, né? Then we're going to go add layer, add vector layer, and then make that 100. We're going to say add. Let's have a look and see what happens now. I doubt that anything is going to happen. But then we know there's no point. We can just keep the default. We're going to go load style. And we're going to open, load the style, apply. Ooh, there's quite a big difference. Much less res, much more red. Much more red. Okay, so it's quite sensitive. It's much more sensitive. Okay, so if we go the opposite, so it was 10, so let's make it 2. So we're going to make that 2. So that's quite sensitive. This minimum number of samples in each node. So let's make it 6 because there's 6. Let's make it 6. Run. Because there's 6 of them. Let's make it 6. So it's going to be 6. And we're going to make it 6. That's the beauty of it. You just don't know what you're going to get, what you're going to versus your expectations. My expectations is you're not going to make a difference, and then it makes a huge difference. So we're going to make that 6. Add. Now let's see. It should look much better if it's true that 100 made. Ooh, style, load style. Sorry, man. Load style and apply. Okay. Okay, so let's have a look and see. So that is the 10. So the 6 also, I think the 10 looks much better than the 6 as well. There's the 100. 100 is much more red. 6 is also quite a bit of red. 10 is the least amount of red. I'm just looking at the red. The greens and the stuff I'm happy with. So there's more red. Okay. So that seems to be the optimum. Let's do this last one. I'm going to make that 6. That's going to be the last one that I'm going to work with. And I'm going to make that a 6. And we're going to run. The last one of my DTs. Okay. So I'm going to make that a 6. And we're going to make that a 6. We're going to run that. We're going to go layer, add layer, vector. And we're going to have to remember that was a 6 that we made. 6. We're going to say add, close. Let's have a look and see if that makes any difference. Properties. Categorized. Style, load style. It's quite repetitive. We have to compare it to our original one. No difference. Okay, so the only difference really is this one. This value there. I haven't looked at these ones, but that's obviously we'll have to look further. But I think you guys are getting the gist of it. Okay, so let's quickly look then at which one shall we also look at? DT. Let's look at artificial networks, ANN. So again, ANN, we're going to leave it as is. All these values. There's a lot of them. ANN. We're going to leave them. Yeah, there's too many of them. Let's just first run run a normal one. To see if there's anything. Run. Before we start being fancy. Paste dot SHP. So we've run the model. Yep. Then we're gonna run the classification. Let's see, this one is taking quite a bit longer. Okay, it's done. Okay, so let's see what this one now. As I said, every time there's a lot of surprises happening here. So let's quickly, no, why is it not giving, what did we save it now as? What did we save it now as? Verification. Yeah, here it is. So why didn't it open now? So we're going to go that one. So we're going to go layer, add vector layer. We're going to add. Is not a valid or recognized data source. Why? Why? Dot SSH segmentation at ANN. Did we run it? We run it. What's the problem? Output results segmentation underscore a dot a. Okay, so let's go layer, add layer, vector layer. Open. So why is it not here? All the DT stuff is there. Close. Let's have a look and see. I don't know why it's not close. Okay. So let's run it. Segmentation model. Let's run it. Okay, it's done. Let's quickly go and have a look and see if the model is there. There's segmentation. And there's the boost. So why is it not giving me the ANN model? That model. So what's going on now here? There's the model. Output model. But I'm concerned that it's not displaying the model. Come on, where is it now? Hope there's not an issue with our network again, that it's not. You know what? Match is found. Okay, so let's quickly do something else. I think maybe, come on, what am I doing? Concentrate, concentrate. AN, make it another in. Make it another in. All these other things are still, let's delete that one there. Must I add in here something? Let's do that now quickly. Run. Let's see now. Nope. Okay, so there's nothing there. Okay, so let's go. Number of neurons. Let's make it 6. I don't know what, I really don't know. We'll have to go and figure out this one. There's the neurons. Let's have a look now and see. There we go. So it wanted that. There we go. ANN. Okay. 6 neurons. Okay, so let's now go in, just for simplicity. Keep it the same, and I'm going to say underscore 6 neurons. Okay, so we're going to run it. That's it. We always will figure it out. Don't panic. We'll figure it out. So we're going to go view, add vector layer, and we're going to go, should be there now. There we go. And we're going to open. So add. There it is. Let's see what it, whether it has potential. What the hell? What the hell is this now? And apply and close. Okay, so we're gonna go this one. Let's quickly look at the, it's got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it does it, but it puts these things under different names. So we'll have to go and format. See, it gives it not the ones add to the 6, it gives it in these format. Why? I don't know. What we now need to do, we see the red is obviously agriculture. This is obviously, so the green is water. This little purple is, so we'll have to, what we'll have to do now is reclassify it to say, okay, training, farming is green. So in this case, red. So it's this one, must be green. Okay. Then we know the mountains is that gray. The mountains in this case is yellow, so that's going to be that one there. It's going to be that color. Okay. We know the pink is the veld, which is brown, so which is this color here, which is brown. Then the water is this green is the water. This water, yeah. And then this purple, what's we've got now? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then this color here, I think this is the red. Yeah. For, you can see the problem with the sand. And then the issue with the sand, which is this color here, which is the sand. Which is that color there. Ooh. No. can't be. Can it be? Potentially. We'll have to have a look and see. Let me just save there. We'll have to drill in. See, it's got water here. Okay, so let's have a look. It's got the red here, which is the urban areas. You can see this is the problem with it. There's the water. The green. Green is the agriculture. You can see that the green is the agriculture. Yeah. Sand is that one. I don't know. There's something when we have to reclassify them. Um, okay, so what we'll have to do now is we have to save this color scheme. So if we then make it, let's say, number of neurons. Okay, so let's just arguments. Okay, so what are we going to do is we're going to go, oh, properties. And we're going to go style, and we're going to say save style. And we're going to save there as segment 2, ANN. ANN. And we're going to save it. So let's quickly do one more. Let's make that, let's go 60. Just for interest sake. Let's see what it does. Underscore 60. Let's run it. Underscore 60. And we're going to go here 60. And then, okay, so I've just ran it. Let's quickly have a look now. We're going to go view. We're going to add layer. We're going to say add vector. And we're going to make 60. We're going to add. And then we're going to go properties, style, load style. Ooh, you can see there's quite a big difference. I wonder if my felt, yeah, I think the felt and the sand should be swapped. The felt, yeah, I think that should be swapped. So the felt should be that, and this one should be that. Yes. That one should be swapped around. There we go. So with the 60 neurons, that's the outcome. And the 20 neurons, that actually doesn't look too bad. Except that, yeah, a little bit more red. But this, as you see the sand problem, this actually does not look too bad. Now, the next phase obviously would be to convert this into a raster so that we can compare it with our other segmentations. But this actually doesn't look too bad at all. Especially compared, yeah, you can see that. That is definitely sandy area. Yep. So I've got the, so let's just properties. So I'm going to save this layer, save this style. Replace it, yes. Okay. This actually doesn't look too bad. It's got the water. It's got the urban areas. Okay. There's some there that shouldn't be there. Mountains, that shouldn't be mountains either. It's got one or two glaring issues, but in general, this is doable. And I think if we do the segmentation a bit better, then this thing actually could work. So that was with the 6 neurons. So that was with the 6 neurons, and that is with the 60 neurons. So the 60 neurons seems to be the better option. Okay, so let me just pause there for now. What I want to do is I want to use this and then actually include the validation vector and see whether that makes any difference. But we'll do that in another video, because I first have to add, and obviously the values here we can play around. So let's use this as a basis, because that's actually quite good. Then we're going to play around a little bit with within the artificial neural network. We're going to play around a little bit with the variables, or with the attributes that we can change. Because this is now quite intriguing. Yes, there's a lot of options here. Anyway, let's pause there for now, and then keep this for a follow-up video. Okay, with that's it. Hope you enjoyed it. And as I said, please, please like and subscribe and share the video. And I'll see you on the other side.